I will start now. Thanks for coming. I'm going to talk about the OpenSUSE base system. So probably nobody has heard this term before because I just invented it. So I will start with some motivation and then talk about two different parts of this base system. Namely, one part that we call base:build. So this is actually a project name in the OpenSUSE build service. This is why you see these strange names. The other one is base:install. And then I will briefly talk about the Hackweek project we did 2 weeks before. We developed base bootstrap, which is basically that bootstrap clone for OpenSUSE. And then some nice packaging advice that fell out from that project, because we have some broken packages which are uselessly making your images bigger and stuff like that. So the usual problems. So what is the motivation? The motivation is to care a little bit about the core part of OpenSUSE. So all the parts that are not colorful, not moving, not making sounds, which is usually where people spend most of the time, because it's of course very well appreciated if things start moving or making sounds. So if you care for the core part, it's often hard to see the benefit, but it's still there. Of course, somebody needs to do it, and from time to time you get an itch which creates a issue, and then you work on it. And yeah, well, so it's like an ongoing project for now, I think, 2 years. And so every hack week, maybe we will work on it a little bit. So the first project, which is actually the first one we started with, is to look at base:build, which originated in the idea to reduce the number of packages we install into our auto-build change root environments. So like before we did that work, we, for example, by default installed other strange stuff that usually nobody uses, but of course packages had started to depend on them being available. Like the VI existence was actually necessary, because at the moment we removed it, we got like for one package, I think it was, I don't know, but it detected, oh well, there's VI available, so use that as my default editor. So actually you get interesting dependencies of our RPMs on the installed set of packages that are not in the build requires. So we thought we need to clean that up and identify sort of a small set of packages this way, where you don't need any other packages to build these packages. And this is of course one way to identify what is this core part of OpenSUSE. And the motivation at that time was to first reduce the build time, because as in AutoBuild and also in the build service, we are doing bootstrapping of packages. That is, once you have cycles in your build dependencies, the packages get rebuilt over and over until there's no change anymore. So if you have lots of dependencies with lots of cycles, the build time usually is very large. And of course, for small packages, the most time we spend is actually setting up this build change root. So if you reduce the amount of packages you install there, you will get faster package build times. So this set of core packages is also the set what you would need to cross-bootstrap somehow if you want to bootstrap on a new architecture, like if you have ARM or I don't know, there are not that many new architectures these days, but it's probably mostly interesting for embedded architectures. And on a side note, there's, maybe you know that, Linux from scratch. So this is basically building up your Linux distribution from source, from scratch. And this basically, from the set of packages you need to build manually, is exactly that set of base build, because if you have done that, then you can use our regular build script and just automatically build source packages. But you need all of them to start with using build. So let's then open source it from scratch. So how does this base build look like? At the moment, I say at the moment because it of course changes if people add dependencies or packages get split, packages get removed. It's 80 source packages and 164 generated binary packages. There are still stuff in like Tickle or GPM and less. Maybe so the Tickle dependencies is because we run some test suites which require djgnu, which requires Tickle. And GPM is, I think, I don't know, but it's oh yeah, right, Ncurse has GPM support, so it needs the library. And less is there because we require man to be present, because that is the only thing that sets the man path. So otherwise, the script that compresses all man pages afterwards wouldn't find the man pages. So that's a more interesting dependency. And this actually takes about half a day to bootstrap in the build service. But this is of course because in the build service you have only one CPU per package, and there are packages in like GCC, glibc, and Automate which require on a single CPU quite a amount of time to build. So this is actually the build dependency graph of this base system, and I can zoom in a little bit so that you can read it. Can you actually read it? I can zoom in more. Okay. So you see there's stuff like util Linux. So the I only read it.
Next slide.
Well, it actually doesn't work, but I can just, I don't know why. Try again. So, the green boxes are those packages we always install in the build root. And they, of course, have dependencies and build dependencies. And so you get, for example, this. So we always install man, and for that reason we get this. Because, well, man wants a pager. The blue ones are actually those that have sources. And the regular black ones are the generated binaries. So for example, from the GCC for suite package, there are generated a lot of sub-packages, like Ada, and the other ones are somewhere down. So this is actually not all dependencies, but it's all dependencies, but the graph is transitively reduced to reduce the amount of arrows, because otherwise you wouldn't see anything. Because everything requires glibc for building, and everything requires the compiler for building, so yeah, wouldn't make any sense. So there are more GCC packages below. You can also see that we require, of course, gettext and techinfo for building, because we have like techinfo man pages and translations. There is, of course, bash, because in every change root you need it. And there's basic pseudo-specific setup stuff like file system, which is setting up core parts of the build root. So that's enough for that. So what's now the base install part? The base install part is the opposite of the building part. So we are no longer interested in build dependencies, but only in dependencies that get pulled in at install time. That is what we want always to the end could install the base install with a single RPM transaction without it complaining. So not just unpacking the RPMs into some directory, but using RPM for that. And of course, for install, we are interested in the size of the installed system. Because if you want to install an embedded device and you only have 64 megabytes of flash, then you only have 64 megabytes of flash. So, at first, one thing we use the install part for is, of course, again, for setting up the build root, because there we install all the packages and also install their dependencies. So, but in this one, you, for example, don't need RPM itself in principle, because you don't need a package manager in the installed system if you don't want to install additional packages. So, in principle, everything that this magic package AAA base depends on should be that minimal system. So this AAA base is, I think it's for historical reasons named that way. So I don't know the history, but yeah. It's basically a sort of a hook package to provide initial stuff, like there's an init tab inside, there is, I think, some scripts that massage at distribution updating, stuff like that. So there's a magic package. So if you look at the install dependencies of a base, then you can see, for example, that you get PAN support pulled in through a login program. You get you get UDEF for device files. You get CPIO. I don't know why we get CPIO. Probably, I don't know. And we get info, because we have info pages in the system, and in the post-install rules, we require, of course, info to update the directory. And then we have some, probably mostly script-related uses of find utils. We get call utils, so you can do ls and stuff. And of course, you get a bash, also because there are scripts inside. So if you install all these dependencies of a base, you indeed end up with change root, where you can change root into you have a shell, you can do basic file system operations. So this is exactly what you want, but it's still 35 megabytes in size. So it's pretty big. So the biggest part of that is 10 megabytes of translations for call utils. But I heard the rumors that this is already fixed and split to a separate package. And then it's just adding up. There's no other big offenders left. So for example, in former times we only had one cracklib directory, and because our PAN configuration requires PAN cracklib, it was another 10 megabytes of the direct dictionary file. But now this one is empty, and this works as well. So if you not only want to change root into such a system, but also want to be booted and maybe log in, then you need to think about having a kernel, an init.rd, and that should be it if you again have this AA base. So in the installed system itself, you don't necessarily need a kernel as init.rd, because if you want to boot over network, you can just fetch all these things over network. You also don't need to build this init.rd inside the image. This is actually one thing we have done in the Hackmeet project to sort of better split the init.rd building from the installed system. And the same is, of course, also true for the bootloader. So you don't need to install grub into the system just to have the bootloader, to have a bootable image. So if you add the kernel to this one, and then you will get something like this. That is, the kernel requires the mk-init.rd and some module init tools because of all the kernel modules. So our default kernel is basically possible. You need some more scripting stuff that is otherwise not required in the A-based packaging. But this adds another 73 megabytes because it adds about 60 megabytes of kernel modules. So and this 60 megabytes you wouldn't necessarily get rid of if you take out the kernel image itself from the system. Because if you want to like support USB hot plugging, you would need to load the kernel modules on demand. So you have to have them installed in the system somewhere. Now, let's look at how bad things get if we choose to add, for example, the OpenSSH or DHCP client to be able for a machine that booted to get a network address and maybe can then remotely log into it. That actually only pulls in all the SSL stuff from the OpenSSH, and I think Kerberos support should be somewhere there. Oh yeah, right, Kerberos 5. OpenSSH also requires PVD utils for some reason. PVD utils is where stuff like changing your password, changing your full name, all this LW related stuff is in, which also means that you get in the LW libraries. And that's actually not very bad. It adds about 20 megabytes to the AA base system. Or you can maybe add an X server, so you have an X terminal, or even a small window manager after that. So if you had X server, where the XVM and Xterm stuff nicely is pulled in via dependencies from if you install the X or X11 server package, then you get a whole lot of X-related packages. But it's good that you don't pull in a lot of other stuff. So this adds up to 106 megabytes in total. But this is without the kernel. So if you have a kernel inside the system, then you get this other 70 megabytes. So, but it's still not bad. But for the 64 megabytes device, it's already too much. And you get also stuff like fonts, which probably add a lot to the image size here. And once you pull in, for example, our smallest window manager, I think it's the IBM Lite, then you get also desktop backgrounds, which is like 10 megabytes of JPEGs. So it adds another 60 megabytes for some reason. But it would still fit on today's average size USB stick, which would be about 2 gigabytes, I think. So that's already nice. So but what you can see is that it would be possible, for example, at that point, to somehow weaken the dependency on all this desktop data, or maybe get rid of it completely and shift installing of that to some other magic package which, for example, could provide some product-specific configuration or install stuff. Also, what we saw right here, the OpenLDAP support, which is built into PVD utils, could be maybe modularized out, so that if OpenLDAP is not available, the binary still would work, but just without OpenLDAP support. So, in the Hackweek project, we try to automatically build bootable systems from simple package selections to just test if you select this A base and the kernel, if you actually can log in. So if all requirements are really written out in the RPMs, and if you remove some, if the system still works. And so we, in the wiki, created this base project wiki page where we summarize also the past work and especially the base bootstrap work. And then the base installer package contains an image builder, this base bootstrap script, which is similar to that bootstrap, so that only sets up a FOSDEM hierarchy with some packages. But also a script, which is called, I think, base installer, that builds bootable images. At the moment, we build just QEMU images. For other images, you need to manually configure what modules you want to load into the init.rd, so you can find your hard disk controller and stuff like that. Yeah, that's the base bootstrap script. You can actually use that also for QA of your post-inst scripts and your pre-requires, because we set up everything in one RPM transaction. You, for example, can see that some packages call uname, but it's not yet installed. You can see all the errors from the install scripts. You need to go over these and fix the packages that we found doing that. And yeah, the base installer builds the image. I have a code demo prepared. I do already prepared image. So this is an image which only contains kernel, the mkinit.rd, and a base. What I'd like to show is after I have logged in. For example, you can see libgcc is not required, but glibc complains that pthread cancel will not work if that is the case. But nobody requires it, so hopefully it's just a false warning. American keyword. So we have even sort installed and new, everything is put in. And what you can see, the system is about this 100 megabytes, and the biggest offenders are user and lib. So let's just try to look into these. And you can see the kernel modules with 64 megabytes. Not so interesting to look into, but maybe user share. And this is actually the locales, as I already said, it's only about 14 megabytes. So these are the biggest offenders, and the rest is really spread out. It's probably single useless documentation files, stuff like that, or binaries you really don't need in such a basic system. Not too much in /bin. But user bin is really crowded already. So this was just to show that it actually works. I can show you, if you are interested, on my own laptop afterwards outside or tomorrow, some more images with more interesting stuff. So what's the result of this project? It's more or less that for the core packages, you want to use file requires. For example, you don't want to require core utils, but for example, bin cp, stuff like that, to be able to just throw busybox into a repository and get that automatically substituted for core utils if it's available. And you want to prefer C programs. In any of the pictures I showed you in there, I saw the C++ standard library, which would add another, I I think 4 or 5 megabytes with all its dependencies. So if you can avoid C++, then it's nice. And you also want to restrict your scripts to Bash, maybe also Perl, but please only core parts of Perl. So we have actually split the Perl package into two, and it's to a base package, which is I think 2.5 megabytes big, with the interpreter and some core modules. But if you then use more fancy stuff, you get the full 50 megabytes Perl package. So if you can code it in Bash, even if you like Perl more, do it with a normal shell still. And also, PostScript in core packages should be avoided if possible. It's usually not necessary. Because if you have PostScripts, you really need to audit your scripts that you insert all the required pre-requires and possibly not create cycles in that case. Because if like Bash pre-requires Bash, then it's a problem. Because yeah, it might not work out. And of course, split your packages. Like I think Dirk has split the translations of Boyutis into a separate package, which would get rid of 10 megabytes in that case. Or the kernel modules could maybe be split from the kernel image package. Or maybe we could even split the kernel modules on topics. So everything that's not hot plug related, we could omit from installs that have the kernel and the init IDE outside of the system. Follow the shared libraries policy. There are still lots of packages that have a library. That is the only thing that is required from a package. But you also have some fancy binaries in that package that require in turn complete other stuff. So package your shared libraries separately, where it makes sense, of course. And this is actually something we thought about, like we ship a standard PEM configuration, which requires, for example, REST manager and cracklib and some extra PEM modules and lots of stuff. But it would be nice to split out such default configuration from the package, in that case PEM, to some other magic package that would be customized for like a product. For example, we have the init IDs in AA base. It could also be in system 5 init package. I don't know why it's not there, why it is in AA base. And so the PEM configuration could also be in AA base, in theory. So that's basically it. Are there any questions? Yes?
What's the mechanism by which you loaded the minimal cracklib dictionary? Is it specified that as a dependency the normal cracklib dict?
So actually both dictionary packages provide, I think, cracklib dict. So that's actually cracklib dict small and cracklib dict full or big. And our package solver, so I wrote an own package solver for that. It has actually the policy to prefer the smaller if it has a choice. My package solver. Yeah. So it would be, of course, a policy that could be enforced also for the subsolver, maybe, if it knows about the package install sizes. I don't know if that's in the solve files, but you could, if you have a choice, prefer the smaller one, or even prefer to be more fancy and even look at the requirements pulled in from that decision and solve for the smallest complete system size, which I don't do. I only look at individual package size. But it helps in most cases. You could do that. Yeah. And it's, of course, it makes sense if you want to build small images. More questions?
Exercises, I guess, have been all involved in distributed systems. People try to do the same space calculation for 64-bit systems. How much difference is it? Small system?
I think it isn't, at least if you are on Intel hardware, the difference shouldn't be too big. So all these numbers included complete debug information, because in the build service the debug information is not stripped.
I was wondering, because your kernel modules have been only 64 megabytes, and I remember it's mostly 8 megabytes, which is
okay, that could be, but that's a reasonable difference. That would be like 20%, something like that. It's maybe a little bit less, because data files, once your system gets bigger, they start to dominate the picture. Yes?
Do you have an estimation what is the smallest possible size? So if you leave away the debug info, if you leave away all the useless documentation, fonts, background images?
Well, I can remember in former times, a bootable Linux system fit on a floppy disk.
Nowadays?
Nowadays? Oh no, no idea.
No idea.
Well,
is 64 megabytes, is this a target?
Well, 64 megabytes should certainly be enough if you have your kernel extern, your init to have to run an external. I think it's completely reasonable to expect that to be enough. I don't know if it will work out, but it should.
Would it be worth creating a custom distribution which builds base system size packages which exclude all these info things? So you can drop all those dependencies on things like info, for example, and then build a distribution based on that meta distribution.
Well, actually, Embedded does stuff like that. So they don't build any documentation. They also, I think, exclude all languages but one by default, stuff like that. So it certainly would make sense for a specific product if it's really space constrained and you hit that constraint, that you try optimizing on that. But you can also use RPM. If the documentation is properly marked, you don't need to install it. I don't know if you can get rid of the postings requirement easily. For you require info as a pre-requires because of the posting script. I don't know if you can disable that at install time.
You can sort of provide info.
Oh, of course, yes. So we cheated at one point. The base release packages was always seen there, provides Perl bootloader. Because otherwise you get full Perl. But you don't need Perl bootloader because we don't build the init RD. So this is about useless requires in the system.
GDC is essential as a requirement, or did you ever try to think of building with microwave GDC or anything like that?
Well, that would touch more the build requires thing. So you could try mirroring the base builds thing and substitute, for example, use libc and see if everything builds. I probably not, but yeah, maybe. Or you can, for example, substitute LDAP with nothing to get rid of LDAP support, stuff like that. So it should be fairly easy to do in the build service, to experiment with that by editing the project configuration and building against, for example, use libc, yes. And stick in, for example, BusyBox and see if we have strange scripts that require more than POSIX compliant commands. I bet we have.
Yeah.
Well, I think there's also, I don't know if it's still live, this MicroSUSE project. This was only Uli.
No, we stopped doing it.
So it's probably something that could be revived with people that are interested and actually have those embedded devices to try it out. And you can also look at Embedded. They have basically, they do also very special things aside from Debian. So they rebuild everything, every 200 packages they use.
I'm just
some
wondering
magic stuff.
if there's any sense in us building a really, really tiny script base system for the build service that has all these packages built without any extraneous stuff, and then that rebuilds them to build the actual ones that we distribute as OpenSUSE. So you go a bootstrap, whatever, minus info, then recreates itself with the info completely there. And you might get a 50 megabytes image which we can use as a base build.
So what I think was Jan Blum was working with me on that, and he's probably looking at all the maintenance stuff related to our products like SymClient, stuff like that, which also have related problems, and are solving them like in a manual way by selecting individual files that go on the Kiwi image. So it's probably, we should just try in the base distribution to get rid of the easy things, and once you start running into the problems where you would rebuild with different options, then I think we can think, for example, of providing a base set of packages with reused dependencies in a build service as target you can build for. That's a good idea, actually. Yeah.
We can prepare our spec files with some with and so then with something and without something.
Yeah, right.
So that other projects can link against the source and just say without any.
Or you could invent like standard names for LDAP and just ignore it for that project. Stuff like that.
And that's why I asked about the crack lib, because I thought there was some flag that was being passed.
No. So the crack lib actually builds both RPMs, the small and the big picture. No more questions? Then, one more question.
Did you try to build without debug info?
Well, it's not possible. Oh, well, it's probably possible in the build service.
Yeah, if you
we have, I think the current scripts for building the images just run strip over all the system before finally building the image. But of course, in the end, the build service needs support for debug info packages anyway, which would then strip, of course, the debug info from the main pages. But it's so we compared the sizes, and in debug info it's only about 20%. So it would reduce the A base system from 35 megabytes to 30 megabytes.
Did you compare only the debug info section, the strip debug info section, or everything with it?
No, just the image size, which results if you strip or don't strip. So it's only C code, so usually the debug info is not that big. More questions? No, then thank you.